What up, guys? This is DeBoerium, and we're going to take another look at the flat earther known as that guy, as he doesn't understand physics, once again. We're also going to expose his dogmatic behavior. So without further ado, let's take a look. First, let's expose his dogmatic ways when dealt with beliefs that oppose his own. Shortly after uploading my first video explaining how he did not disprove gravity, he freaked out more than just a little bit, and quickly uploaded his own video restating exactly what he said in the first. I had a short dialogue with him, trying to explain that since objects accelerate towards the ground, there needs to be a force, as Newton's second law states that. Here's what he said. It's not a law. You're assuming acceleration. You're assuming gravity. Classic globe-tard BS. You think space is fact. You think gravity is fact. Cavendish is not science. All Cavendish proved was lead attracted lead. Use any other two substances and tell me how it works out for you. You should be able to use a rock, and a bigger rock. Using lead and lead is not a scientific demonstration. What an idiot. Here, I'll keep an ad hominem counter on the top right. Once you started the insult, you have automatically lost any type of credibility in an argument. Anyways, it's extremely ironic of you, since when you responded to another video, calling you an idiot, you called him out on it. Hey, but I guess it's okay when you use it, right?
Loved it. Black holes.
Now, at this point, we can clearly see that the black hole he's talking about must be the empty cranial cavity he calls a skull.
All that. It was so cool. I loved it. And then I questioned it. And
So far, ad hominem.
Just how insanely laughable.
Now that I established you are a hypocrite, let's move on to the rest of the ad hominems you used in response to me. Here's my favorite one. I just have to read it to you. You need a higher IQ to understand this concept.
I'll have to ask my accountant about that.
Anyway, I saw that the conversation wasn't going anywhere, so I suggested a debate. His response was to block me. So yeah. Anyways, let's respond to some of his comments and explain to him why he's so demonstrably wrong, before we get into today's video. So let's address this one here, where he claims I assume acceleration. So let's define acceleration for you, that guy. Acceleration is change in velocity. Now let's do a demonstration, because you seem to dismiss all claims made that are not physical demonstrations. Okay, so I have this pen here. Its velocity is 0. I drop it. Its velocity traveling down was greater than 0. Thus an acceleration happened. Here, I have this another example. Right now it has a velocity of 0. I push it, has a velocity of greater than 0, thus I accelerated it. That required a force. Now if I do the same thing and pick it up, I used force to accelerate it upwards. And then if I do it again, I accelerated this way with force. So why is it whenever I drop it, it is not a force? That is what you fail to explain. Now this equation right here might scare you a little bit, as it states for every acceleration, there has to be a force. Now, what I just demonstrated is that the pen fell, so it accelerated towards the ground, which means there was a force applied to it. Now, for you to disprove this, you have to disprove one of the most fundamental laws of motion. Now, good luck with that. Now let's address the Cavendish claim, where he says the Cavendish experiment is not scientific because it's only been done with lead, which is wrong. It was also done by Harvard students with tungsten balls. It was done with rocks. It was also done with bowling balls. So yeah, not scientific at all. Now with that out of the way, we can finally look at today's video of that guy showing us once again how he managed to disprove gravity and space with the bottle. This is gonna be great.
What's up, YouTube? That guy coming at you again with another quick video and a scientific demonstration this time. Sorry, we're talking about the vacuum of space and our atmosphere and testing the theory that gravity is what's holding the air and water and everything to Earth. So let's take a quick look at the theory real quick. We have water down here. We have thick atmosphere. It thins out as you go up. This is mid-atmosphere, upper atmosphere, lower Earth orbit, and then deep space. So we're told gravity is what's holding all this. And the theory of gravity also states that the closer you are to the center of mass, the more gravity you will have affecting you. The more gravitational force will be acting upon you. So, that means closest to Earth, you'll have the most gravitational pull. The further away you go, the less gravity, until eventually you leave Earth and then there's no gravity acting upon you.
Now this is wrong. Gravity follows an inverse square law, which means over the distances that you are describing, there would be a very small difference in the gravitational acceleration you would feel, say if you were standing on Earth, or 20 miles up. And with it being an inverse square law, the range of gravity is practically infinite, just as a magnetic field is.
So these molecules up here have the least amount of gravity acting on them, and they're the closest to the vacuum. This does not follow science. So how can we test this theory? With this simple little experiment here. I have this little water bottle. You can hear it as I squeeze it. Obviously, it's going to pull the air inside of it. The air rushing inside a vacuum has nothing to do with the pressure of the air down here at sea level. Neil deGrasse Tyson and the other preachers will love to tell you that it's the air pressure forcing itself inside the vacuum. No, that's, if I open this jar right now, that's the air forcing itself inside the bottle. When it's just sitting here open, the air will fill the bottle. That's common sense.
So you don't understand that vacuums don't pull, and you dismiss that part of science completely. Where do I even start? First off, you were proven wrong in 1643 when the barometer was invented. So if the weight of the atmosphere is not pushing the water into the bottle, then this basic function of a barometer would not work. As a barometer measures the current air pressure with a similar setup like yours, except for they use mercury. If the vacuum were to be pulling the mercury up into the bottle, then it shouldn't rely on atmospheric pressure. But we do know that the level of mercury drops when a storm is approaching, as storm systems are low-pressure systems. It directly causes the barometer to create a larger vacuum, as there isn't as much air pressure pushing it up the tube. With your logic, a larger vacuum should pull harder on the mercury. You also would not be able to explain what caused the vacuum to grow in size.
But when you create a vacuum, and I put my finger over here, that's a vacuum inside there. It's a very, very weak vacuum. And when I let my finger off, it will want to equalize. This is two different pressure systems. Right now I've created a vacuum inside. It's not equal to the air outside here anymore. It's different. It's a different pressure system inside this bottle than the one surrounding it here. That's why when I let my finger go, it will equalize every single time. That's the second law of thermodynamics in basic explanation.
The second law of thermodynamics deals more with heat, but I guess it can be applied here as well. It states that entropy can never decrease with time in an isolated system. An isolated system is usually taken to be outside the reach of external gravitational and other long-range forces. So what that is saying is that there is no isolated systems that occur naturally, resulting in gravity creating order, if you can call it that.
So, how can we test if gravity is what's holding this air to the ground? We've already pulled the air inside the bottle, but it's still just sitting here, right? That's not really proving anything. So we'll have to stick it in water. I'll let it go. I'm not helping this in any way. I just set it in the water after I squeezed it, created the vacuum, stuck it inside the water. And it's slowly drawing water inside of it. Physically lifting the water inside of it. That's a lot of weight here. That's quite a bit of water. See, now that was not the water. The pressure of the water wasn't forcing it inside here. I can stick it in here all day. The pressure from the water is not going to force it inside this bottle here. It may to the water line there. After a while, it will get to where the water is level and level off. But I'd probably have to poke a hole up here so it'd have room to breathe, because now there's a tiny little vacuum, or not a vacuum, but a pressurized system inside it. Now once I hold it underwater, it'll pressurize the air inside.
You're right. The water pressure is not forcing the water up into the bottle, but the air is. Like I explained before, you just made a simple, not very functional barometer. What you fail to comprehend is the entire weight of the atmosphere for every square inch is pushing down with 14 pounds of force. So when you lower the pressure inside the bottle, you decrease the 14 psi to something lower, resulting in the higher psi to push itself into that area. To further, we have the same setup you just did. So then we got the atmosphere weight, 14 psi, which is pushing down on the water per square inch, right? So then we got your bottle here, which you created a pressure differential, which is less than 14 psi. So then there'd be a less of a force pushing down. So then a greater force is going to push the water down and up into the bottle, because there's not 14 psi pushing it back down. Now, an experiment done by Evangelista demonstrated that the atmospheric pressure would have to be pushing the water up into the bottle, as he had two tubes, one that was just a normal tube and one that had a bulb at the end of it. He submerged both of them within mercury and noticed that they never went above a certain height. Now this height would be the equal of the pressure pushing down of 14 psi from the outside air. So the outside air would be pushing down, but so would the weight of this water column be pushing down with 14 psi, so it would never go above. And he proved this as he had this one, and it had a larger vacuum. Now, at the time, people thought that vacuums couldn't exist and that they would always pull matter into the area. But he discovered that it's a larger vacuum, so there should be more hypothetical pulling force. But he'd never noticed that. So his conclusion led him to believe that the atmosphere would be pushing it up into the bottle. And we know this is true in modern science.
The point being, sorry. The point the demonstration is making is this tiny little vacuum here that I'm creating with a cheap little plastic bottle. This little vacuum here is nothing compared, I mean nothing compared to this. We can't even create a vacuum strong enough on Earth to replicate deep space. The best we can do is 10 to the negative 6 torr. And the atmosphere, or the deep space, is 10 to the negative 17 torr. And the moon is allegedly 10 to the negative 11. So the best we can do here on Earth is 10 to the negative 6, and we need 8-foot thick concrete walls with a space between the aluminum core, which is an aluminum sheeting core, and you got to pressurize that little gap between the concrete and the aluminum to 20 torr, and the 8 to 6 foot thick concrete walls. That's so the vacuum does not draw the air from outside the atmosphere, the normal atmosphere from outside the building through the concrete walls. It wants to pull the air from outside through 8-foot thick concrete. So they have to put the gap between it, pressurize that gap, and so on.
You were talking about the SPF facility that creates a very large vacuum used to test various spacecraft and other science-related things. Keep in mind, it's much easier to create a vessel to hold pressure than it is to keep pressure out. First off, vacuums don't pull, as I proved earlier. I know math scares you, but I'm going to calculate the amount of force in pounds the atmosphere is pushing on the chamber. First off, we need to find its surface area, and with a quick Google search, we can find its dimensions. Putting it into a surface area calculation, you get 55,000 square feet. Times that by 12 to get inches, and times that by 14.6 for atmospheric pressure, and you get 9,600,000 pounds of force pushing on the chamber. I think that justifies the 6 feet of concrete they have, and also proves that vacuums don't pull. It is pushing itself in the chamber.
The point is, it takes a lot to keep that thing from collapsing. These vacuums are very, very strong. If you put that vacuum chamber to 10 to the negative 6 torr and poked a hole this big, it would suck a human body through there. It's very strong. It would liquefy a human and suck it into that thing like nothing.
Sorry, bud, that only happens in movies. Anyways, that hole is about 2 millimeters, and the amount of force that would be pushing you into the bottle would be 7.3 pounds if that were to be a perfect vacuum. So yeah, that doesn't work at all.
But here, this tiny thing won't even barely suck a piece of wet tissue paper inside of it. And here I am lifting water. I can stick this in the ocean and lift water up.
Wow.
See how it's going higher than the water level? It's literally physically picking it up. Whooping gravity down here. How is that possible?
No, gravity is just fine. What is happening is the weight of the atmosphere is greater than the weight of the water in psi, so it rises.
If you're in school, if you're in a physics class in college, or you know a physics professor, bring this up to them. How is this tiny little vacuum lifting water molecules here on the surface of Earth, where gravity is strongest? It's whooping gravity's ass to pick up water, which is way, 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 way heavier than these little air molecules here.
Yes, the water weighs more than those molecules up there, but gravity is still affecting them near the same. The thing you do not understand is that the weight of the entire atmosphere is pushing the water up into the bottle.
These molecules are much heavier and much more dense, right? And this tiny vacuum is picking it up from the surface. But this vacuum can't pull these tiny little molecules that don't have barely have any gravity pulling them.
Well, on the surface of the Earth, you have the entire atmosphere to help you push the water up into the bottle. But once you reach near space, there isn't much of a pressure difference, as there is a gradual gradient that slowly turns into space. There's not a hard line from space to atmosphere.
This is the problem we have with your model. Science is the problem with your model, okay? If you're a globe believer. I always assume I'm talking to a globe believer, but I got to stop doing that. But this is the problem we have with the globe. If you believe in the globe, you have to explain this with science. So I'd love to hear back from like a physics professor or something on something like this. I've never heard a professional or a physics professor or anybody like explain this with science. Anyways, till next time, keep it flat. I'm out.
The professor would tell you the same thing I have. There's no contradiction, just false understanding. Anyways, stay literate, and I'll see you next time. Yours truly, DeBoerium.